All right, guys, so we're going to be solving 3x3 systems. What's a 3x3 system? We're talking about a system of equations that has 3 equations, and in each of those equations we have 3 variables. It's no longer just x's and y's. We have an x, a y, and a z. And we don't just have 2 equations, we actually have 3. So we should feel very comfortable solving a 2x2, right? And what do we mean by 2x2? 2 equations with 2 variables. We're not talking about the In-N-Out burger. So right here, we want to produce a 2x2 system, 2 equations with 2 variables, because we know how to solve those. We don't know how to solve these. So our goal is to convert this to a 2x2 system, and then we'll be able to solve that 2x2 system. How do we do that? Let's read step 1 right here. Use 2 of the 3 original equations, modify them to get a variable to cancel. That's pretty simple and straightforward. So let's go to this system. We need to decide which 2 equations we're going to use, but even before that, let's decide, what do we want to eliminate? Do we want to eliminate x's? Do we want to eliminate y's? Do we want to eliminate z's? What do you guys say? You guys want to go for x's? Okay. So if we wanted to eliminate x's, which 2 equations would we use and which one would we modify? You want to use the first and the second equation? It's pretty simple, right? So let's use that first and second equation. And how would we modify the first equation to get that x to cancel? Times it by -2. So everybody please put parentheses around that first equation, put a -2 on the outside, and we're going to multiply that whole first equation by -2. So let's rewrite it right here, nice and neat. -6x, -2y, plus 4z. And of course, that's going to equal -2 times 10 is -20. By the way, when you do this on your own, you might have decided to cancel out x's. Your neighbor might decide to cancel out y's. Or somebody else might decide to cancel out z's. It'll look like if you guys are doing totally different problems, but if you do the right work, you should be able to get to that same answer. There's many roads to the same place. Anyways, we did modify the top equation by multiplying everything by -2. The bottom equation, I'm just going to rewrite it. So again, I just rewrote the second one right below the modified top one. And again, my whole purpose of modifying the top one and combining it with the second one was to get the x's to cancel. And we are only canceling out x's because you guys told me to. I probably would have canceled out y's or z's. But anyway, we're canceling out x's. So let's combine the lines. The -6 and the +6 eliminate. We end up with a -4y. We end up with a +5z. And we also end up with a -22. Ladies and gentlemen, that is step 1. Let's box this equation in, and let's call this new equation number 1. Okay, this is what we call new equation number 1. NE number 1. So if we go back to the notes, that was step 1. Once again, it said use 2 of the 3 equations, modify it to get a variable to cancel, creating a new equation which now only has 2 variables. You see, before we had x, y's, and z's. Now we just have y's and z's. Okay? So let's move on to step 2. Go back to the original, use the one equation you have not used yet. Okay? So which one have I not used yet? The third one, right? The bottom one. So x plus 4y plus 3z equals 7. So we want to use that third one, but what else does it say? It says use that one you haven't used yet and combine that one with any other to get the same variable to cancel. You know what? Let's underline the main points of step 2. Use the one you have not used yet and also get the same variable to cancel. That's very important. Use the one you haven't used yet and get the same variable to cancel. So again, I'm going down to the one I haven't used. You know what? Just to make it more understandable, I'm going to rewrite this one down here. Okay, let me rewrite it. So this is the one I haven't used yet. I just rewrote it because I'm going to use it now. Now, I need the same variable to cancel. What variable canceled over here? X's. I need the x's to cancel also. So which one would I want to use? The top one or the middle one? I already rewrote the bottom one. That's the one we haven't used. I have to use it. But what am I going to use it with? With the top one? Okay, so let's rewrite the top one right on top of it. 3x plus y minus 2z equals 10. Okay, so now I need the same variable to cancel. I need the x's to cancel as well. If I would have decided to cancel out y's at the beginning, I would need to cancel out y's. If I would have canceled out z's, I need to cancel out z's. But because we decided to cancel out x's, we need to cancel out x's. So how am I going to get these guys to cancel? How am I going to get those guys to cancel? Multiply the bottom one by negative 3. So the top one, we're not going to do anything to it. I'm just going to rewrite it. Let me rewrite it right here. And the bottom one, I am going to modify it by multiplying by negative 3. That way the x's will cancel. So I'm going to end up with a negative 3x. Negative 3 times 4 is negative 12 with the y. And negative 3 times 3 is negative 9 with the z. And equals negative 3 times 7 is negative 21. Are you with me? Okay. So why did I modify the bottom one? So I can eliminate the x's. That was the whole purpose of it, to eliminate the x's. Let's combine the lines. The x's eliminate. I end up with a new equation that reads negative 11y minus 11z equals negative 11. And that is new equation number 2. That is step 2, ladies and gentlemen. Right? So why was it so important that we canceled out the same variable, right? If we canceled out the x's here, we had to cancel out x's down here, because that's the only way that we'd end up with 2 new equations with the same 2 variables, y and z. So step 3, if you read step 3, it's to create a new 2x2 system. All right, create a new 2x2 system. So you take your new equation from step 1, your new equation from step 2, and you simply put them together as a new 2x2 system that we should all be able to solve. So let me rewrite it. Negative 4y, this is my top equation, plus 5z equals negative 22. And the bottom one is negative 11y minus 11z equals negative 11. Okay, so this is step 3 right here, our new 2x2. And we should all be able to solve 2x2s with linear combinations. Now, even before starting to solve this thing, I mean, we could deal with these bigger numbers, or the bottom equation is divisible all by 11. That'd make it a lot easier. You guys want to do that? Okay, so let's divide everything by 11 on the bottom equation, just to modify it. Okay, so divide by 11, actually by negative 11 would even be better. So the top equation I'm going to leave the same. It's negative 4y plus 5z equals negative 22. The bottom equation is going to become y plus z equals 1. All right, so now what would I do to cancel out either y's or z's? It's up to you. Multiply which one by 4? The bottom one by 4. Okay, so let's put parentheses around the new modified bottom one after dividing it by 11. And we're going to multiply it by 4. So again, the top one is going to stay exactly the way it is. So I'm just going to rewrite it right here. And the bottom equation, when we distribute the 4, it'll become positive 4y. It'll become positive 4z. And it'll become positive 4 over here. And now we're ready to combine the lines. And the y's eliminate. And 5 plus 4 is 9 with the z. And negative 22 negative 22 plus 4 is negative 18. So that becomes a simple one-step equation. We're going to divide by 9. So z equals negative 2. That is one answer. How many do we need? 3. Oh. Right. Yeah. So this is actually, see, step 3 and step 4, they kind of mesh together, because step 3 was create your new 2x2 system. You might as well just solve it. Solve that 2x2 system. We already have one answer. Let's find the other to the 2x2 system. So let's plug in this negative 2 where? Into the bottom one's nice and easy, especially after dividing everything by 11. So plug in that negative 2 right there, and you're going to have y plus z, which is really negative 2, equals 1. And now you'll be able to solve for y. You simply add 2, and you will get y equals 3. So there's two answers. We need the third. And this is your fourth step is just substitution, right? So let's go back and plug in both of those answers into any three variable equation to find that missing variable. So obviously we're missing x. So which one should we use? The first one, the second one, or the third one? It doesn't even matter, to be honest with you. Let's go with the first. Okay, so let me rewrite that first one. I want to rewrite it down here. It's 3x. I don't know x, so I actually write the x plus y. I do know y. What's y? 3. You could use parentheses, but there's nothing to multiply it by, so you don't really need to. You know what? I'll put parentheses. And then minus 2z, minus 2 parenthesis, e equals 10. Again, I just copied the entire top equation of the original 3 by 3 right here, and I'm plugging in the 3 for y and the negative 2. I'm going to plug it in for z. So there's the negative 2 right in there. Let's do some math. We have 3x. What is negative 2 times negative 2? That's positive 4. So we really have plus 3 plus 4 equals 10, which is really 3x plus 7 equals 10. Let's start solving this thing. Subtract 7, subtract 7. We'll have 3x equals 3, which means x equals 1. Ta-da! We found our three answers. It only took 12 minutes, but we did find them, right? How are we going to state our answer? It's not an ordered pair, it's an ordered triple, right? It's actually three numbers that are in alphabetical order. So we're going to use it as a coordinate. 1, comma, 3, comma, negative 2. And that is actually a location in three-dimensional space, XYZ plane, as opposed to just an XY plane. We'll get to that later. Right now we just want to be able to find these answers. Whoops. So again, step 3 and 4, I mean, it doesn't have to be exactly like this. Step 3 was to create your new 2 by 2 system, right? Get your new variable equation from step 1, your new variable equation from step 2, and create a new 2 by 2 system. You could say on step 3, and solve. Okay, solve your 2 by 2, right? And then if you did that, for step 4, all you have to say is substitute and find your other answer. So maybe that would make this a little bit easier. Step 4 would just be substitute and find your other answer. Substitute and find other answer. Okay, so obviously this is a ton of steps, and obviously it's a ton of math. It's a ton of opportunities to make mistakes. You got to be very careful when you do this. Don't work fast, work slow. If you work fast, you're going to make mistakes. I make them all the time. Let's understand these rules better by making a flip chart. Check this out. I want you guys to grab 3 pieces of paper. So first thing to do is get your 3 pieces of paper, and you just want to kind of leave maybe half an inch, right? So you're going to just put them right on top of each other, just like showing half an inch on each. And notice there's a slight crease right here. That's where I'm going to start folding it. Let me show you. I'm starting to fold right there. That way when it comes over, you end up with this. So once you fold it over and you have a nice crease, you could actually staple it up here. And this is what we want, guys. We want a flip chart that's going to walk us through solving a 3 by 3 system. So as a title, solving 3 by 3 systems, make it as nice as you want, right? Step 1 will be right here, step 2 will be right there, step 3 and step 4. And down here at the bottom, I put extra examples and special cases. Extra examples and special cases at the bottom. That's because there's an extra tab. So anyway, on step 1, you could write it in your own words or just something that'll get you started. So like for step 1, you got to pick 2 equations and cancel a variable. That's exactly what I wrote. Okay, so for step 1, right here, this is not even, we're not even unfolding it yet. I just put step 1, pick 2 equations and cancel a variable. Now if I want more details, I need to open up this front piece, right, and see actual step 1. Check this out. So I'm going to open up this front flap, and you should have this right here. So I did write the entire step, use 2 of the 3 original equations, modify them to get a variable to cancel, thus producing new equation number 1, and that only has 2 variables. And then I took the example that we just did, I copied it again up here, and I want to demonstrate step 1. So what was step 1? Step 1 was to pick 2 equations and get a variable to cancel. So as you can see, I modified the top equation by multiplying it by 2, and I ended up with, instead of 3x, 6x plus 2y, and so on and so on. So I actually show me modify the top equation, put it up here, kept the middle one, put it right there, combine the lines, thus producing new equation number 1. This is new equation number 1, and that's what step 1 is all about. You don't feel like you have to copy. Don't copy it right now. Right now, just watch me. That way you'll know what you're doing in a little while. Of course, you're going to be using the notes to write your steps. The notes is on that half sheet of paper. Down here it says step 2. There's obviously not enough space to write the whole step, so I just wrote some keywords that'll work for me. You need to decide what those keywords are. Step 2, go back, use the one you have not used, and get same variable to cancel. Emphasis on the same variable, right? So when I flip that one over, you're going to see that I have not used the bottom one, and I picked the middle one, and I modified it to get the same variable y that I did on the previous one to cancel. So if you decided to cancel out x's, make sure you continue canceling out x's. If you canceled out y's, cancel out y's. And this is my new equation number 2, right? And I have the entire step that was from your notes right here. I have the abbreviated version out here. And then if you flip it to the next tab, step 3, you take your new equation number 1 and your new equation number 2 from the previous 2 steps, and you create your new 2x2 system. This is my new 2x2 system, right? And obviously the quick explanation is right here, down here by the tab where it said step 3, create a new 2x2 system. Now inside I actually show how I created that new 2x2 system with new equation 1 and new equation 2 from step 1 and step 2. And then I take this new equation. I might as well solve it since I have plenty of space. So we solve that 2x2 system, and we get the answers x equals 1, z equals -2. So for my final step, step 4, it's substitute your answers to find your missing answer. Okay. And then you would show that you plug in your x and your z into any of the original 3 x, y, z equations, and then find your z value that way. Okay. So that's what we're doing for the next 10 minutes or so. So let's get going and use that same math example that we already did in class a couple of minutes ago.